Hello all, this is Sagarika. Welcome to SAGU'S Math. Today's topic is the second part of induction method. We already solved 5 problems of previous video and now move to second video from 6 to 10. Okay, first question is 1 square plus 2 square plus 3 square plus up to n square is equal to this. Okay, similarly same process, step 1 to prove P1 is true and step 2 to assume Pk is true and step 3 to prove that Pk plus 1 is true. Similarly putting here for LHS P1 1 square which equal to 1 and right hand side 1 into 1 plus 1 this equal to okay 1. So LHS is equal to RHS, that implies P1 is true. Next move to step 2. Step 2 1 square plus 2 square plus up to k square is equal to this. That means only to put here n is equal to k into k plus 1 into 2k plus 1. Okay. In step 3 we have to prove that it is true for k plus 1. That implies here putting k plus 1, here also putting k plus 1. Here 2 into k plus 1 which equal to k plus 1. Here k plus 1 which equal to k plus 2. Okay. Is equal to this. Okay. Now to prove from left hand side. ठीक है 1 square plus 2 square plus up to this. That means from equation 1. Okay. Or from step 2 we got 1 square plus 2 square plus up to k square is equal to k into k plus 1 into 2k plus 1 by 6. Now taking k plus 1 to outside or common. Okay, that means only let k into 2k plus 1 which equal to 2k square plus k into 1k by 6. Okay. Now taking 6 as LCM, 2k square plus k, here 6 into, here will be 6 into k plus 1 which equal to 6k plus 6. That's equal to k plus 1 by 6 into 2k square plus 7k plus 6. Now here we can write 7k as 4k plus 3k. Okay. Taking 2k as common from the first two values 2k into k plus 2 plus taking 3 common from this k plus 2 which equal to again taking k plus 2 as common to k plus 3. Okay, which equal to right hand side. Okay, so pk plus 1 is true. Since pk plus 1 is true, that means we can say pn is true for all n greater than equal to 1. Okay. Now move to question number 7 which equal to 1 plus 2 square plus up to 2 to the power n is equal to 2 to the power n plus 1 minus 1. Okay. That means here n operates as 2 to the power n. Okay. That means first term is constant, second 2 to the power 1, next 2 square, next 2 cube plus up to this. That means first term will be 1 plus 2 because 1 plus here n we put 1. That means 1 plus 2 to the power 1 which equal to 3. Right hand side 2 to the power 1 plus 1 minus 1. Okay, which equal to 2 square 4 minus 1 3. That implies since left hand side equal to right hand side P1 is true. Now move to step 2. Step 2 assume that Pk is true. That means 1 plus 2 square plus up to 2 to the power k is equal to this. From this equation we can put here 2 to the power k plus 1 minus 1. Okay. Plus 2 to the power k plus 1. Here equal to this plus this. That implies 2 into 2 to the power k plus 1 because of 2 to the power k plus 1 which equal to we can write by the formula a to the power n into a to the power n is equal to a to the power n plus n. That means here 2 to the power 1 and here 2 to the power k plus 1, which is equal to 2 to the power 1 plus k plus 1. 2 to the power k plus 2 minus 1. Okay. Now move to question number 8. Pn is equal to a plus ar plus ar square plus up to this. In all cases, you have take the question as Pn. Okay. For n is equal to 1, P1, that means a plus a into r to the power n. That means first on fixed a, and from these we put the value of a, that means a r to the power 1 a r square plus up to dot dot. That means n applies on power of r. Okay. So for n is equal to 1, we have a plus ar. First term of P1 is a plus ar. Taking a as common, rest 1 plus r. Or we can write it a into r plus 1. Okay. Right hand side to putting here n is equal to 1 a into r to the power 1 plus 1 minus 1, which is equal to r square minus 1. We can write it r square minus 1 square by the formula of a square minus b square, a plus b into a minus b. Similarly, here r plus 1 into r minus 1. Cancelling this, left this. Now, LHS equal to RHS, that means P1 is true. To step 2, assume that Pk is true. Okay, this is our Pk value. Now, by step 3, a plus ar square plus up to a r to the power k plus 1. That means in place of n, we will put k plus 1. Okay. That's equal to a into r to the power k plus 1 plus 1, which equal to r to the power k plus 2. Okay. R to the power k plus 2 minus 1. Now, putting a plus ar square plus up to a to the power k value, a into r to the power k value is equal to, by equation 1, which equal to a into r to the power k plus 1 minus 1 by r minus 1. Okay, from equation 1. Now, taking r minus 1 as LCM. That means r minus 1 cancel. Left a into r to the power k plus 1 minus 1 plus a into r to the power k plus 1 into r minus 1. Okay. Now multiplying this, a into r to the power k plus 1, here a into 1, which equal to a plus a into r to the power k plus 1 into r minus a into r to the power k plus 1. The same terms are cancelled, only left a into r to the power k plus 1 into r. That means here r power is equal to 1. That means a into r to the power k plus 1 plus 1, which equal to a into r to the power k plus 2. Okay. Minus a. Taking a as common, a into r to the power k plus 2 minus 1. Okay, pk plus 1 is true. Since pk plus 1 is true, that means pn is true for all all r greater than equal to 1. Okay. Next, question number 9, which is 4 plus 10 plus 16 plus up to this is equal to n into 3n plus 1. Similarly, same process, the left hand side of P1 is equal to 4, right hand side 1 into 3n plus 1, which is equal to 4. Step 2, assume that Pn is true for n is equal to k. Okay, 4 plus 10 plus 16 plus up to this equal to k into 3k plus 2. That means in place of n we will put k. Okay, in next term we will put in place of k, n is equal to k plus 1. Okay, step 3. We have to prove that pk plus 1 is true. That means 6 into k plus 1 minus 2, which equal to 6k plus 6 minus 2. which will be 6k plus 4. Right hand side, k plus 1 into 3 into k plus 1 plus 1. Okay, which equal to k plus 1 into 3k plus 3 plus 1, which equal to 3k plus 4. Okay, let's check k plus 1 into 3k plus 4. Okay, here equal to 6k plus 4. Now left hand side, simplifying this. Okay, 4 plus 10 plus this. From this to this value, its value is from step 2, which equal to k into 3k plus 1. Now we can put in this place k into 3k plus 1. From this to this, k into 3k plus 1 plus 6k plus 4, which equal to 3k square plus k plus 6k plus 4, equal to 3k square plus 7k plus 4. At right hand side, 3k square, k into 3k, 3k square plus 1 into 4, 4 plus 1 into 3k, 3k plus k into 4, 4k, which equal to 3k square plus 7k plus 4. Okay, listen. Here are 4 differences. Why I wrote 6k minus 2 here. Okay, that means the previous term of 6k plus 4 is 6k minus 2. Since there are differences, 4 difference. That means 4 plus 6 difference. There are 6 difference. 4 plus 6. 4 plus 6, 10. 10 plus 6, 16. Similarly, the previous term of a 6k plus 4. That means the less than 6. The value is less of 6. 6k plus 4 minus 6. The previous term will be this. That means 6k plus 4 minus 6 equal to minus 2. That means the term is 6k minus 2. Okay. Now question number 10. 1 by 1 plus 1 into 2 plus question number 10. 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 up to this. Okay. This is a very important question for your exam. Okay. Let's taking Pn is equal to 1 by 1 into 2 plus up to this. Okay. Left hand side 1 by 1 into 2, that means here in place of n we will put 1, n equal to 1, that means 1 into 1 plus 1, which equal to 1 by 1 into 2, 1 by 2. Right hand side putting n equal to 1, 1 by 1 plus 1, 1 by 2. Assume that pk plus 1 is true. Okay, which equal to up to 1 by k into k plus 1 is equal to this. Second step, step 3. We have to prove that Pn is true for n equal to k plus 1. That means 1 by 1 into 2 plus this. That means in place of n we will put k plus 1. Here we will put k plus 1 plus 1, which will be k plus 1 into k plus 2. K plus 1 into k plus 2. Okay. Right hand side here we will put n equal to k plus 1. Here divided by k plus 1 plus 1. Okay. That implies k plus 1 by k plus 2. Okay. Now, left hand side, taking left hand side of this 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 2 plus up to this. That means its previous term is 1 by k into k plus 1. That means the value from this to this is equal to k by k plus 1. Here we will put k by k plus 1. Okay, plus this. Listen, k, we can write k is equal to k plus 1 minus 1. 1 are cancel, plus 1 minus 1. Rest k. That means taking this k plus 1 minus 1. Similarly plus here equal to 1. We can write 1 is equal to k plus 2 minus k plus 1. Okay. Difference between two consecutive number is equal to 1. K plus 2 minus k plus 1. Okay. Which equal to we can write by this formula. A plus B by C, we can write it as A by C plus B by C. Okay. Which equal to K plus 1 by K plus 1 minus 1 by K plus 1. Okay. Here K plus 2 by this, K plus 2 by this minus K plus 1 by this. Yes or no? We can write or not? Yes, we can write. Now cancelling this, which equal to 1 minus 1 by k plus 1. Here k plus 2 cancel, which equal to 1 by k plus 1 minus k plus 1 cancel, 1 by k plus 2. Here see minus 1 by k plus 1 plus 1 by k plus 1. Those are cancelled. Only left 1 minus 1 by k plus 2. Taking k plus 2 as LCM, k plus 2. K plus 2 into 1, k plus 2 minus 1, which is equal to k plus 1 by k plus 2, which is equal to right hand side. Now, p k plus 1 is true. Okay. So, Pn is true for all n is greater than 1. Okay. Similarly, we will solve like this type of problem. In the next video, we will solve some different type of induction method questions. Okay. That means question like I'm telling 16 to the power. In next video, we will solve 16 to the power n plus 10n minus 1 is divisible by 25. Okay. In next video, we will solve this type of a problem. Okay. Thank you.